Dear student, let us continue with Module 2. In this lecture video, we are going to study applications of compiler technology. So we have the different applications of compiler technology. As of now, we know that the compiler is used to convert the high-level language into the assembly language. The programmer will write the program in the high-level language like C, C++, Java. Then, and corresponding compiler will convert it into the corresponding assembly language. This is the one application. But apart from this, the different other applications are also there which we are going to study in this lecture video. The first application is implementation of high-level programming language. So compiler technology compiler is used to implement the high-level programming language into assembly language. Let us see. Generally, higher level programming language are easier to programming but are less efficient. That is, the target programs run more slowly. Since uh, higher level language, it are more easier to understand, more easier to write, and less error prone. But it is very slow uh, to run by for running to the processor, and processor will not understand the high level programming language. Programmers use a low level language, have more control over a computation, and can in principle produce more efficient code. But those programmers who write low level language like assembly language or object program, they have more control over the low level language. Unfortunately, lower level programs are hardware harder to write and worse, still less portable, more prone to errors and harder to maintain. Lower level language, it is first harder to write, harder to understand, more error prone, and it is very hard to maintain. The many shifts in the popular choice of programming languages have been in the direction of increased levels of abstraction. So C was the predominant system programming language of 80s. Many of new projects started in 90s. Then C++, Java, introduced in 1995, gained popularity quite quickly in the late 90s. So during 80 to 90, 95, more programming languages got developed like C, C++. And their corresponding compiler also got generated, which will convert the high level language into assembly language. So the two unique features of the object-oriented programming language like C++ or Java is data abstraction and inheritance properties. Data abstraction means the whole data can be abstracted in one module, and inheritance means features of one class, one object can be inherited by another object. So both of these have been found to make programs more modular and easier to maintain. So as the time gone, then the more flexible and more easier and more modular programming languages got developed, which were easier to maintain, and corresponding compiler also designed to maintain these high level languages. Next is optimization for computer architecture. The rapid evolution of computer architecture has also led to an insatiable demand for new compiler technology. See, day by day, new technology, new computer architecture, new hardware devices are getting designed. So as the new architecture of computer is getting designed, then new compiler technology is also getting designed. So almost all high performance systems take advantage of same two basic techniques. So all the high performance systems have two features. One is parallelism and another is memory hierarchy. Parallelism can be done at a different level. One is at the instruction level, where multiple operations or multiple programs will be running or executed simultaneously by the processor at the processor level, where different threads of the same application are run on different processor. Next one is memory hierarchy, that we can build very fast storage uh, or very large storage, but not storage that is both fast and large. So memory hierarchy means that whole data we can store in the system in a hierarchy way. In the hierarchy way, for one file we can put in another file. That file can be put up in another file, and like in hierarchy way, we can store the data, and that is like that we can store the huge amount of data that has increased the data storage capacity. Third application of architecture is compiler design is design of new computer architecture. In the early days of computer architecture design, compilers were developed after the machine was built. Earlier, first of all, computers were built, and by seeing the architecture of the compiler were getting designed or developed after the uh, computer architecture design. So, but in a modern computer architecture development, compilers are developed in the processor design stage only. During the processor design only, compilers are getting developed. Which processor, what is the 32-bit processor, 64-bit processor, based on that compiler is also getting designed for 32-bit or 64-bit. And the compile code running on simulators is used to evaluate the proposed architectural feature. And the compiled code, it is will be running on the simulator, and proposed feature of computer is getting evaluated. So the different computer architectures we have nowadays, RISC and CISC. So nowadays we are having the reduced instruction set computer architecture. But earlier we used to have a CISC, complex instruction set computer. So many instructions are getting simplified, and it is made reduced instruction set computer architecture. So during CISC time, uh, first computer were designed, then compiler were designed based by seeing the CISC instruction set. But uh, during the RISC, in the RISC architecture, the compiler were designed during the processor design stage only. Next application of the compiler technology is program translation. So first, binary translation. Compilers technology can be used to translate the binary code for one machine to that of another, allowing a machine to run programs originally compiled for